Hey guys, how's it going? Today we're going to be playing around with logarithms, and I think before we could do too much of that, we need to get a couple properties down. So here's the first property. Go ahead and copy that. Alright, so now if you notice, it says we have the log base b of m times n. Okay, these two things, m times n. The log base b of m times n. And look what happens. This property breaks it up into the log base b of m plus the log base b of n. Okay, that's the first one. It would be helpful if you would memorize that. Okay. All right, here's the second property. This time I have the log base b of m divided by n. All right, the log base b, this time of m divided by n. Now this is going to break it up into two logarithms, just like the first one, but can you make a prediction of what it will look like? All right, notice this one is log base b of m times n, and it breaks up into log base b of m plus the log base b of n. This one is this log base b of m divided by n, so let's see if your prediction was right. We have the log base b of m minus the log base b of n. Okay? And finally, we have a third property that says the log base b of m to the nth power. Okay? And let me just show you something really quick. If I have something like this, if I have the log base b, for instance, of m to the fifth power, okay? Well, wouldn't that be the same thing as the log base b of m? M to the fifth power is m times m times m times m times m, right? Okay, and wouldn't that break up into 5 logarithms? Wouldn't that be the log base b of m plus 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 the log base b of m, right? Just like this property up here. Okay, since there are 5 m's, we break it up into 5 logarithms all added together. Well, isn't this just the same thing as the log base b of m 5 times, right? 5 times that. So basically, the shortcut for this is to take this 5 and just drop it out in the front. So this is going to equal the log base b, it's going to equal 5 times the log base b of m. Okay? So whatever the power is, you just bring it out to the front. Okay? So in this case, our power is n. So in general, this is just going to turn into this. Whatever the power is, bring it out to the front. So it's going to be n times the log base b of m. Okay? All right, so let's do a couple examples using these properties. Here's first example. We're going to use a couple facts that the log base 4 of 3 is equal to 0.792 and the log base 4 of 7 is equal to 1.404. Okay, we're just going to use that to do these examples. So here's our first example. We have the log base 4 of 3 over 7. And we want to know what that equals. And we can do that now without a calculator because we know this guy and we know this guy. Watch this. We're going to use this property, one of these 3 properties up here. Okay, we'll use this property here. So this turns into the log base 4 of 3. Since it's divided by 7, we're going to go minus the log base 4 of 7. All right, now we know what the log base 4 of 3 is. It's 0.792. It says it right there. So this is 0.792. This is minus the log base 4 of 7, which is 1.404. So minus 1.404. Okay, and then you can take your calculator, right? Turn it on, clear it. 0.792 minus 1.404 equals negative 0.612. So negative 0.612. Okay, let's try another one. Let's try the log base 4 of 21. Uh-oh. How can we do that? How can we do that? Well, look at 21. Can you think of any two numbers that you can break that up into? Certainly. 3 times 7, right? So this is the log base 4 of 3 times 7. We're going to use this property up here. So break it up into two parts. Log base 4 of 3 plus the log base 4 of 7. The log base 4 of 3 is 0.792, so 0.792, plus the log base 4 of 7 is 1.404. Now just add those together, okay? So 0.792 plus 1.404, and we get 2.196. All right, so these aren't as mysterious as they seem. Let's do another one, okay? How about the log base 4 of 49? All right, anybody recognize 49? That's right, it's a perfect square, so you could write this as the log base 4 of 7 squared. All right, bring this 2 out to the front, so we get 2 times the log base 4 of 7. We know the log base 4 of 7 is 1.404, so this is 2 times 1.404. Multiply, you get 2.808. Okay? All right, so that's how that goes. Those are pretty fun. I don't really mean fun, I'm sorry. I shouldn't have said that. That was mean. Okay, let's do something even more fun. Part B, expanding logarithms, okay? Now you can go backwards and forwards with this, okay? Let me give you one example. We have the log of 3x to the 4th, okay? All right, now, before you take that 4 and move it out to the front, don't do that. That 4 is only attached to this x. So if we're going to expand this, we're going to break it up into multiple logs, okay? Since it's multiplying, this is going to be the log of 3 plus the log of x to the 4th. Quick question, what's the base? All right, good, it's 10. Remember, if you don't see a base there, it's 10. Now you can move that 4 out to the front. So you have the log of 3 plus 4 times the log of x. Okay? Let's do another one. All right, we have the log base 5 of 4x over 5y. Now this could be tricky, okay? Here's how I do it, okay? A lot of students make mistakes here, okay? And if we were in class, I would let you guys run with this, but for now, we just don't have the time, okay? So I'm gonna break this up into anything in the numerator gets added, anything in the denominator gets subtracted. How many logs am I going to break this up into, by the way? Okay, it's going to be the log base 5 of 4. There's also going to be a log base 5 of x. There's also going to be a log base 5 of 5 and a log base 5 of y. Okay, so now we just have to break this up into 4 different logs. Anything in the numerator is going to have a plus in front of it. Anything in the denominator is going to be subtracted. So this is going to be the log base 5 of 4. There's an x up there, so plus the log base 5 of x. This is down in the denominator, so it's going to be minus the log base 5 of 5. And then that's also down in the denominator, so minus the log base 5 of y. There's one more thing we can do. Does anybody see it? Does anybody see it? Look at this guy right here. Notice the base matches this. Doesn't this equal the power right there? Remember we learned that in our last lesson? Okay, so if these equal each other, then it equals the power. So the power right there is 1. So we have the log base 5 of 4 plus the log base 5 of x minus 1 minus the log base 5 of y. Okay, let's do another one. And by the way, the book might ask you to condense logarithms. You're basically just going to go backwards, okay? You're basically going to go backwards. That's all you have to do, okay? All right, so here we go. We have the log of the 5th root of x cubed. Okay. All right, so here we go. I'm going to rewrite this like this. This is going to be the log of x cubed to the power of 1/5. Okay, that's how I'm going to rewrite it. Okay, now watch this. Can't I change this by multiplying it together? So don't I get the log of x to the 3/5? All right, now just move that out to the front. So we have 3/5 times the log of x. Okay, pretty simple. All right, let's do one last thing before I run out of time. Change of base. Change of base. And this is where you get to use your calculator. We have the log base b of x is equal to the log of x over the log of b. You're going to have to memorize this. Now watch, what's great about this is if you look, what's the base right here? That's right, the base is b. What's the base here? Aha, what's the base here? Ah, the base is now 10. Okay, what's great about that is now we can use our calculator a lot easier. Okay, remember this button right here? If you press that button, what is the base automatically? That's right, it's 10. We don't have to go inside the calculator and find it hiding in there. Okay, so let's just do a couple quick examples and then I'm done. So we have the log base 3 of 8. Okay, all right, so let's change that. Change of base. Okay, see if you can do it. All right, here we go. We have the log of 8 over the log of 3. All right, and now all you have to do is plug that in your calculator. Log, can you all see that? Log of 8 equals, that's 0.903, so that's 0.903 over the log of 3, right? So log of 3. And that's 0.477, so 0.477. And now just divide those. Okay, now just say 903 divided by 0.477 equals, and that's 1.89. Okay, so 1.89. Now you can get a better answer by just doing this. You can just go in parentheses, the log of 8 divided by, okay, parentheses, the log of 3, so the log of 3, hit it, equals, and you get 1.89, same thing, okay? So anyway, let's do one more, I have time. All right, so we have the log base 5 of 7. Okay, go ahead and change the base. All right, so that's the log of 7 over the log of 5. Put that in our calculator, use parentheses. I usually don't do it this way because there's so many parentheses and I think students get confused. So the log, here we go, so you can see it. The log of 7, so I have log of 7, close parentheses, divided by, and I need parentheses, the log of 5. Hit enter and I get 1.209. 1.209. Okay, and that's it, y'all. All right, guys, I hope you have a great day. If you need anything at all, just find me in Zoom or send me an email. All right, peace.